Welcome back, guys, to the next video here. So we're just going to be solving exponential equations graphically this time. It's going to be a pretty short little video. I'm going to be doing most of this solving using Desmos so you can see what it looks like, but you'll have to practice using your calculator, using the intersect button on your calculator, and I'll just practice so that you're comfortable with the calculator when it comes to a test situation. Desmos won't be around all the time. If you feel like it, you could use Desmos while you're at home, but please practice using your calculator to solve these kind of questions. And again, we're solving these graphically because we haven't learned how to solve these algebraically, because in the previous video, we solved these algebraically when the bases can be changed to be the same thing. When the bases cannot be changed to be the same thing, how do we solve these? Well, one way to solve them is using what we call logarithms. But logarithms are next couple lessons from now. So right now we're just going to solve these graphically because that's the only way we can solve these ones as is. All right. So let's see what we have here. Now, when we're talking about this, we actually have, there's more than one of these two methods here. There's more than just two. But these are the two main methods to solve anything graphically. And this doesn't change since, say, solving polynomials graphically or solving trig functions graphically or anything graphically that we've done before. You could just graph one side of this equation to be y1, and then we can just graph the other side to be y2 on the other side, and then just find out where they intersect each other. I want to find those intersection points. Okay. Maybe I could, maybe rather than using Desmos here, I'm just going to use our little emulator here. I'll load that up in the background while we get this kind of set up here. Method 2 requires us to move everything to make it equal to 0. So that's like solving a polynomial, like, or factoring, or using the quadratic formula, which would be right above my head. Is that right there beside the column? You can't really see it too well, but that's where the quadratic formula would be. So we could use that method as well. So if I'm going to solve it that way, oh, those are great straight lines. We can make it equal to 0, move everything to make it equal to 0, leave it 0 on the other side, and just plot the one graph instead. And we plot the one graph, we just find out where it is across the x-axis, because that's y is equal to 0. Technically, you can put a line on that and then look for the intersections as well, kind of like what we did here. Sometimes it's easier to see the intersections when it crosses the x-axis, because the x-axis is just a flat line, rather than looking at a couple of curves like we're looking over here to see where they cross each other, or if they cross each other more than once. So maybe this method here makes it just a tiny bit easier to see what it looks like. So I'm going to start off with the original equation, and then we're just going to make it equal to 0. So I'm just going to move everything to the right side this time. All right, you can move it to the left side, to the right side. It doesn't really matter which way you move it. So I'm just going to write that term, this 5 to the power of x plus 1. I'm going to write that over here. So I'm just going to subtract that whole term over here. So now we're going to graph this, and let's see if my calculator start up. Oh, here's my calculator. All right. All right. Let's move my face over here. So I want to graph what this looks like. I'm going to graph both of these, and then we can see which way do you think is easier, which way do you think is nicer. I'm just going to go back to my standard window here. And if there's anything in your calculator, might as well just clear it out. So let's start off with the first method here. The first method, just graphing the two individual equations separately. Now remember, you have the older style of calculator, make sure you put the exponent in brackets. You don't have to do it here, but if you had an older style calculator, this part up here would have to be in brackets, because this +1, you want to make sure it stays in the exponent. But in these newer calculators, if it's in the superscript there, then it's in the exponent. And then we're going to do the same thing here. We got negative x minus 2. Let's drop down out of the exponent and then go +3. So it should look like that. So if I graph that, oh, yeah, I can see there's an intersection point here. So if you want to, it looks like there's only going to be one. So you go second trace, 5, enter, enter, enter. As long as it says intersection, you have your point. So you can go over here and say x would have to be negative 0.3. I don't know, it doesn't specify how many decimal places, so let's use 3 decimal places. So we're going to round that up to 0.310. Now I should get the same answer on this side over here. So let's go back to our equation. Okay. Now we're going to write this as one big equation. So we're going to go 7 to the power of negative x minus 2. And then we're going to go plus 3, and then minus 5 to the power of x plus 1. Okay, hit graph. Oh, just 1 second. All right, so as you can see that on the graph here, there's a one intersection point here. If I just grab that, I could probably pull that over. Oh, most of the time I could. There it is right there. So this graph, you can see on the graph itself, that little intersection point right there. All right. So we're going to find that. So we're going to go trace, second trace, I should say, intersect, enter. Oh, we don't have an intersection point, so can't do the intersection on this one. So if we only have one line like we have here, we can't do intersection. So if you want to, you can add in the other line. You can add in the 0 for this side, so that when I graph, you don't see it there, but there technically is a point there. So we go intersect. Now we can go enter, 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 and you can see we got the same point. Now, if we didn't have the other line, so if this line wasn't here, what we could do when we go second trace, because this is equal to 0, so technically we would be looking for the zeros. So you can go 2, but it's going to ask you a few different questions. You can't just go enter, enter. All right, so I'm going to ask you for the left bound. So you're just going to move your cursor slightly to the left of this point. So you just want to make sure that's over there. If there's more than one intersection point, don't move it past the one that you're not trying to find, right? So this is the one I'm trying to find. I want to make sure I'm immediately to the left of that. You hit enter. Then you want to go to the right over here. You want to make sure that this cursor is to the right of that point. Then hit enter. If you did it correctly, you just hit enter again, and you should get the same point here. All right. So let me just delete that. So we get the exact same x value. X is equal to negative 0.310 as well. All right. So those are your two methods for solving these graphically. All right. So we can solve all these things graphically that way. Pretty simple, pretty easy. But if I want to try to solve these algebraically, we're going to have to use what we call logarithms, which we'll learn later on is just the inverse of an exponential function, where they kind of switch the x and y's and puts the x in a good spot where we can actually solve for it. It's not just as simple as switching x and y, but that's essentially what you are going to be doing. All right. That was a quick little video on how to solve these graphically. The next video, we're just going to solve some word problems instead. All right. And these word problems we're going to have to solve graphically as well. All right. I'll see you then. Bye.